ICPC first. These are the solution outlines for ICPC 2025-2026 online round. The first task was how many? I don't know why they added this task. Like, it's very simple. Basically, they are just saying that one team has 3 people, then n teams how many people? N into 3. That's it. This is the first task. Okay. So so let's move to second task. So this task is pseudo palindrome. Okay. So the task asks us to, is it possible, like we are given array, is it possible to rearrange or permute, basically to rearrange, permute, to make it such that like the cost of the reflection around the symmetric axis, whatever the n minus I minus 1, n plus 1 minus I, sorry, n plus 1 minus I, because n by 2 symmetric point, right? So let's say our array is something like this, a1, a2, but I guess 0, n plus 1 minus I, right? Here, actually they are considering one base indexing, right? So this is the one base indexing symmetric number. So ai n plus 1 minus a. So a1, a2, a3 up to an, each number is paired with this, its symmetric axis around the center. That's the palindrome, right? So all we need to do is make sure to rearrange such that ai minus the symmetric part is less than equal to some given number, right? So the moment they said that, the first thought process in your mind should go around that if we could rearrange the numbers on number line, right? Because the moment we know that something is around this, it's always the sorted part. Like most of the absolute difference stars or any kind of difference stars are related to sorted portion. So the first thing is, like, whenever we need to minimize the difference between numbers, it's always greedily possible that we could arrange them uh, when, like, the difference would be minimal when they are adjacent to each other, right? Same goes for the mean value. If you want to minimum, okay, anyway, like that's the different. It will get more confused on that. A1, A3, AN, right? So the moment we did this, A4, A5, dot, 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 dot. Now if I chose A1, right? If I chose A1 like this, by the way, these are numbers, okay? I am plotting this on x-axis. How we will combine them? Let's consider a simple case. So for simple case, n is supposed to be even. Let's consider that total numbers are even. So each number is paired with at least one number. So greedily, we should pair each number with its adjacent one, right? Because, like, let's say I didn't do that. I did something different. I paired a1 with a3 and a2 with some other number. So what will happen? That the moment we did that, we increase the cost for pairing, cost of pairing, right? So it's always, so let's say I did a1 a3 ka pair and a2 a4 pair, right? So traversal from a2 was huge, like this was this part plus this part, right? So what we could do instead, swap a3 and a2, A1, A2, A3, A4. The moment we did that, the total cost got decreased. Hence, we can say that we can always pair the adjacent number. So when n is even, you can say that you can pair those adjacent number. Uh, so how you could do that? Just sort those numbers, whatever the sorting part is, and how to place them is something like this. Let's say these are the indexes 1, 2, n, but here they don't need the actual placement, right? I will also show you how the actual placement can be. Like actual placement can be easily defined when n is even, right? But when n is odd, you need to consider the extra number. So how would you pair them? Like you would just place simply like this: a1, a2, a3, a4, a5, a6, and keep doing that until n by 2, and you will get the best possible answer. Why? Because it's called, the technique is called greedy exchange, right? Or greedy. Uh, Another one is exchange arguments. The moment we did swap, we can reduce the cost here. Like let's say I did pairing with a1, a3, and a2, a4. The moment I did the swap, my cost is reduced basically. So you can do this swapping multiple times, and so this way you can prove that adjacent numbers are always better to pair with each other. Hence, for even case, this is the one thing. But for odd case, like let's say when n is odd, what will happen is there will be one extra number here in center. Like let's say there are 7 elements, 1, 2, 3, 4, 5, 6, 7. So this number we need to put something here, right? So what does it mean in terms of array cost? A1, A2, A3, A4, A5, A6, A7. So previously what we did was we just pair A2, A3 and A5, A6. But here what we could do is we can ignore one number and start making those differences from the right side of it. Like let's say I ignored A4, right? So I could pair A2, A3 or A1, A2. But I don't think we can do that here. We can only ignore the odd numbers if we can ignore, because before that we need to pair with each other, right? So yeah, I guess that's the case, because the moment we ignore even number, there will be only remaining. Sorry, my bad. It's not the case, because we can also pair a5, a3, no? Yeah. So what we could do is we can ignore one number, at most one number. Can ignore at most one number, right? So if when I'm at a5, either I could ignore a5, and or I could just consider what I could pair a5 with. I could pair a5 either with a3 or either with a4. But let's say I paired a5 with a3. This is done. Whatever benefit, or not benefit, but uh, whatever the limit I had, whatever the allowance I had, I already used that. I had allowance of one number, I already used that. So the moment I did skipping in terms of 5, like I skipped 4 for combining a3, a4, a5. The moment I did that, I skipped one number already. Now after that, if I'm considering the cases, like let's say I'm trying to pair a6 with some number, I can't use the extra advantage that I have, because I have already done that. So you need to use DP for that. Not DP, you could say, but anything. But yeah, you could call it DP. DP I1 is basically, it means you have combined until I. You have combined until I with, you are given with used advantage, or we kind of like already skipped one. Skipped portion. And similarly, DPI0 is that we haven't skipped anything. We are just combining it with previous cost. And that's it. This is our DP. So DPI1 uh, is just dp I minus 2 0 plus the difference, which is I ka portion ai minus ai minus 2, something like that, because we are combining it with that. So this is the one. And similarly dpi 0, you can combine it with dpi minus 2 0 plus ai minus ai minus 1. That's it, I guess, for pseudo palindrome. Anyone have any questions? Like I have also added this in the editorial. Wait a second. This editorial. I will paste. I have pasted in chat editorial. Mhm. This editorial. Okay, I will just write the editorial answer here. That TP I0 is can prefix of length I be perfectly matched. This is to have exactly one unpaired element. Yeah, like the advantage is used or not. Yeah, just little bit different, but the naming is different. But prefix of. By the way, blue pen is comfortable, right? To you guys with exactly one unpaired element. This is the one. So dp of I0 is 1 if dp I minus 2 0 is obviously true. True, it means that the cost is possible and the current pair is valid. Acha, okay, we don't even need to minimize the cost. We just need to check if we can form the pairs or not. Because obviously, like when it is sorted, the cost is automatically getting minimized. Or we just need to make sure that the AI wala portion, whatever the sequence we chose, AI minus AI plus 1 wala portion or plus 2 wala portion is less than equal to D. That's it. It should be AI plus 1 if we consider the sorted sequence, but something like this. So dp I minus 2 0 is true and ai minus ai minus 1 is less than equal to D. This is dp I0 that we are perfectly pairing with each other, and dp I1. You can also use some prefix suffix operations to simulate this. You don't need exactly the dp, so you can also do that thing. This is true if dp I minus 1 is 0 and we are skipping the ith element. Various ways to implement this, not very hard. That we have skipped this, so cost will also not get assigned, something like that. Or dp I minus 2 1 and this is the paired cost that ai plus sorry ai minus ai minus 1 is less than equal to t, either this thing or either this thing. If one of the conditions is true, you can say that dp I minus 1 is true. It basically this basically means that I am skipping the current portion, like the current number, or and this means I have already skipped in the I minus 2th prefix, and I'm combining the current element with the previous one. And these are basically the sorted sequence AI minus 1. That's it. For binary search plus ordered set, we can also use this. Like for what binary search exactly?
Hello.
Yes.
Yeah, like my idea was initially I thought of sorting the given array, and for every element at some index I will just try to find out the lowest element satisfying the given condition, like d minus a of I, the lowest element satisfying it, and I will place it at the end of the array and just remove the element from the ordered set. And can we try something like that, right?
Did you got AC with your submission?
No, like I didn't wrote the contest actually, but I was after seeing the question, I was having an idea of
There is
solving.
this link. If you have your solution, you can also submit it here.
Sure, fine, fine, fine. Okay, okay, okay.
This
Fine.
ICPC. One second, I will paste in chat.
Like I also had a doubt, right? You are leave if in case of odd, we are just doing some DP, like taking added advantage and not right DP of I and of 0 and I minus 1.
Sorry, I didn't listen to you. I was reading chat. One second. Actually, you are the only one who asked. Yeah, like can't we solve?
Yeah, 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 exactly, exactly.
We are solving using DP only, but for odd, like even you can just keep the pairing and check if those adjacent number are less than equal to D, then it's okay.
Okay, okay.
Because in even we can't skip any element, right? The moment we skip any element, uh, for odd we can just use that skip element on the center and we don't care, but for even we can't do that. We had to pair each number with each other, so we just need to check on the sorted part that
Mm.
a1 combine a1 a2 ka difference is less than D, a3 a4 ka difference is less than D, less than equal to D, obviously. A5 a6 ka difference, so it's basically a constraint difference that we can use. We
Yeah,
can't
yeah, got it.
basically, right?
Yes, yes. Right, fine, fine, got it.
But your approach of binary search plus ordered set, I guess you are trying to greedily combine to the center, to the nearest part, something like that, right?
Yeah,
Like
yeah,
you
exactly, exactly, exactly. Yeah.
combine on the number line, but basis on the distance. uh, But how would that help? Like binary search on what element you are doing? Like ordered set, I got little bit of idea, but why binary search?
Let us suppose if we are given with some array, and I will just try to sort the array initially. So let us suppose the first element is some array of I, and we need to pair up with other elements satisfying the condition, like it must be D minus array of A of I or D plus array of A of I, right? According to the given condition.
Okay. But D is fixed here, right? Like we don't care about
Yeah,
that part.
D is fixed and we are at some index array of I. So array of I is also fixed. So using binary search, somehow we need to find other element which is satisfying the condition of this D minus array of I or D
But
plus array of I.
that's why we are choosing the greedy approach. Now, like why we are choosing the greedy approach? Because we know that if I consider adjacent element, the difference will be smaller.
Mm,
Like let's say I'm on number line, this 10, 12, 15, right? The adjacent number is always smaller, like 2, 3. This difference is always small between there. But the moment I choose 10, 15, the distance is incremented between those two numbers and I will get the distance as 5.
but still, yeah, we can pair it up if it satisfies the given condition, right? Like if it is okay, we can just pair it up even
Yeah,
if.
obviously that's why we are saying, right? Like
So
we can skip one number and pair it with other thing. Like let's say my distance is too big for this thing, like 12, 15 ka pair, not 12, 15, but let's say 100, and then I got 102, right? So the moment I got this number, it's obviously doesn't make sense pair 12 and 100, right? That's why we are skipping the highest cost. Yeah, but you could say that I could just skip the highest difference cost and
uh, pair up.
right, and n
Yeah,
minus
yeah.
1 the differences, lowest differences should also work.
Hmm. Yes.
Like we can, like let's say I plot them on number line, whatever the numbers are, a1, a2, a3 up to an. Obviously
Okay.
if I
Yes.
remove one element, uh, I can't use that element, right? So
Yeah, that is why I was using order set to remove the elements
hmm.
after pairing up.
Yeah, but I thought like because my approach was we are skipping, so we can just use DP. But yeah, I guess we can use something like that, that D1, D2, D3, and DN, and remove, just remove the highest portion after sorting this
Mhm.
D1, D2, D3.
Yes.
Just and if the maximum values after that is still greater than D, then we can't solve as a something.
Hmm.
Okay,
I
so
was thinking this actually, so I thought of explaining.
it's okay, it's okay.
I'm not sure. I'm not sure if it works or not, but yeah, this is what the initial thought I guess after looking at the problem.
I'm also not sure because, like, for me, it's better to just do the DP thing. Because let's say when we are remove the highest portion, right? If after sorting, so what will happen? Let's say something like this. Let's say it is between second pen shut off. A6, let's say A6, A7, A8, and let's say A9, right? And
Okay.
A7, A8 wala portion was the biggest difference portion, right?
Okay.
So
Okay.
if we need to remove this difference, whatever the difference is, right? If we need to
Okay.
remove this difference, how will we remove this difference is basically because first we were combining A7 and A8, right? And A6 with
Mm.
other number, right? So
Yes. Yes.
that
Yeah.
was my
Yeah.
condition. No, no, I don't think we can do that because it means the moment I did that, uh, it means I can't combine 7 with 8, right? So either I could combine A6 and A8 or A7, but the moment I did A6 and A8, my difference will always increase. Na? So I am confused now a little bit. A8, A9, A6, A8. This difference D1, D2, D3, and the moment I did A8, A9, I got D3. D2 got incremented to D1 plus D2. If I remove that, I don't think that this will work because this works on the assumption that we are removing one difference and constraint. But the moment I did, I am forced to pair these numbers that the moment I did. So it means the moment I removed this difference, right? From, let's say this was the highest difference and I removed that. So
Okay.
it means I am forced to pair A6 with A7 and A8 with A9. But it doesn't make sure that these numbers are paired already or not, right? So A1, A2, A5, let's say there are five numbers, right? So
Okay.
if I combine A6 with A7 and I remove this difference, it means I have left with five numbers here,
Mm.
and we can't pair these five numbers with each other because we are combining A6 with A7 and we are skipping this difference,
Mm.
something like
Yeah.
that. But we can combine. Okay. So even we combine A6 with A7, A8 with A9. If we skip the difference, greedily possible. Okay, let's discuss it at the last. I
Yeah.
guess
Fine. Fine. Yeah. You can
this
continue
looks
that.
very interesting approach, but I need to make sure. But we will not waste time because we need to discuss all the tasks, and
Fine.
then
Fine.
we will discuss this.
Sure. Okay.
So let's jump to D. By the way, you guys got this thing right, the DP portion. That DPI0 is just we are combining all the elements, something like this: A0, A1, A2, A3, just as we did in even numbers. And DPI1 is just we skipped either this number or some other number in the prefix. But the moment I skipped, I am forced to combine this with this. So something like that. So DPI0 and DPI1 are two states here. Okay. So this one was which one? One second. B1. Okay, so let's jump to C. Guys, if you don't understand anything, please ask. XOR LCM. Okay. So the moment I saw this task, first thing, uh, usually mm, usually authors don't troll you, that they will just make constraint that to make you believe that the solution in certain direction, and the constraints had nothing to do with it. uh, this happens rarely. Source C plus P or C equal to ALCM C. Oh, sorry, LCM of A comma C plus LCM of B comma C. Uh, I will explain you my thought process, how I came up to my solution. Okay. So the moment I saw LCM, I knew my answer is going to be multiple of C, right? And so the moment I just uh, that I thought my answer is like whatever this portion is, right? Or whatever this portion is, this is going to be some T into C, right? Like multiple of C. So what I could select, so maybe it might be the chance that A and C uh, are also, A and B are also multiple of C, something like that. So trial and error portion was there. First thought was my that because of the LCM thing. And second thing, I thought why it could be multiple of C, because the moment I chose prime number with C, the like co-prime pair with C, the LCM becomes P into C. And because here 10 is to what was C? C was 10 is to 7. So 10 is to 7 into some prime number 10 is to 7. So which is still less than equal to 10 is to 70, right? So I thought this might be possible that we can select some prime, and I guess there must exist some solution. But then I thought that uh, it might be possible if prime wala portion might be the solution if XOR was not the case. But here XOR is in the equation. So our solution is not related to prime. Our solution is related to binary somehow. This is a constructive task, right? Like everyone have different approaches, thought processes to reduce thing, right? And mostly it is trial and error, what will work and what will not, right? So then I thought B XOR C, uh, B XOR C, A XOR C, right? So the another thought process is to make sure that this portion doesn't interfere with one another, right? So I thought maybe I could put A equal to 0, but zero, no, A equal to 0 was not possible. So I thought like let's put A equal to C. Let's say A equal to C. Then this term vanishes. This term it becomes equal to 0. And the moment I did LCM A comma C, this becomes C plus something, right? And B XOR C. B XOR C. Uh, I thought so either it could be something related to that, something like this, that C portion is there in binary plus C. This is the binary portion, by the way. Like combining it with give you the big binary representation. And this is C ka binary portion. Binary portion of C. Basically, the suffix or prefix, if you look at it in another way. So this is empty here, and this is some combination of one and zeros, right? And this is C. So the moment I did XOR, and just via thinking like this, I got the solution, right? Uh, so I thought like I could put some ones and some ones here, but then I thought why I'm putting exactly the one here, why I can't put uh, this C here and this C here, because this A equal to C was getting 0, and but just by trial and error I got this number. Basically I don't have even logic for this question, but just trial and error. combination of one ones and zero zeros. But the moment I saw this C, I thought like I could put some binary here, and then why some random number or random binary? Why not just C? So by C, I mean obviously C into some 2 ka power, like by right bit shifting, 2 raised to the power some C 2 ka power plus C could be my portion for B, and A could be C, right? So I tried this combination first, and I don't think this will work because the moment you do B's or C, this portion will get cut, and A's or C, this portion will become 0. So it becomes C into 2 raised to the power, and LCM of A comma C is giving you C. So I don't have any portion to add here. So I need this C basically, right? So what I thought, like, why am I cutting this C? I can just make it 0. So the moment I did XOR with C, this portion will get added with C. So mm, this portion, the multiple of C into 2 ka power will be, so B became my 2 raised to the power into C. This is just to make sure that we are shifting it in at least that much space, so we could combine that it doesn't interfere with the addition part, right? So uh, what I thought, like, just make it like some random number, and the range was very big, like it was 10 is to 17. So I thought, like, just move it around like 10 is to 9. So 10 is to 9 is around 30. So my B was just C, sorry, right shift 30, and my A just was C, and it was satisfied that A is or C plus B is or C. A is or C is basically 0. B B is or C is just B plus C, because I see XOR is basically addition, right? XOR is basically addition when bits doesn't interfere with each other. This is very crucial thing that in constructive task, that XOR is basically addition when bits don't interfere with each other. So here bit are not interfering with each other because I have already pushed it to some extent that it doesn't interfere with each other. And similarly, I have in my session I have taught about ID generation. I guess you have heard about it, that if you are given an ID, something like that, and I could just combine it like this, x into m plus y, such that this doesn't interfere with y, and I could still extract it, right? Like this m is very big number, like let's say 10 is to 5, let's say, right? And x is less than equal to 10 is to 3, and y is less than 10 is to 3, right? So the moment I did x into 10 is to 5, it doesn't interfere with y. It will never interfere with y. And you can also use this in your grid questions, that you can combine two numbers into one ID, and you can easily get x and y from this. Like let's say I combine my ID something like this, and my ID divided by m, and ID modulo m is basically my x and y, right? So similarly, the same observation here, that I will choose such big number that it doesn't interfere, uh, XOR, if it doesn't interfere with C in the binary representation. The moment I did XOR, it becomes addition basically. You don't need to think in terms of XOR then. So it became B plus C, basically, right? And this, an LCM wala portion, LCM of A comma C was just C, right? Because I chose A equal to C, plus B, because B is a multiple of C, big multiple. So this condition became equal, and that's it. So my solution was just A equal to C, B equal to C, right shifted 30 times. That's it. Uh, let's discuss D. Mm, D was interesting one. Any queries in C, by the way? Any queries in C? Okay, so let's jump to D. If you don't have any queries in C. I added indexing. Started with C. Oh, sorry. D, man. Make empty. This was okay. This is very interesting task in terms of geometric visualization, also in terms of permutation cycle, right? So if you have never heard about functional graphs, functional graphs. So functional graph is something like the permutation graph, right? The moment you do, like, let's say I have written 1, 2, 3, 4, 5, 6, 7. If I exchange this number, right, and the indexing is also 1, 2, 3, 4, 5, 6, 7, right, and permutation is also this. The moment I swapped these two numbers, right, the indexes become indexes remain same, but numbers become 7 comma 6. But this creates a cycle, right? 6 7 6 and 7 are in cycle basically, and you can see each number have in degree of 1 and out degree of 1. So functional graph are something like that, that not functional graph exactly, but this is subset of functional graph. But anyway, like functional graph is not the case here. The point is that this exchanges kind of like swap those indexes from their positions, right? Or it is kind of I don't know how to say it, but mm, let's take the example of 5 6 7, right? And the moment I did rotation 5 6 7, let's say I made it 6 7 5 5 6 7. So this creates a cycle that 6 portion is connected to 7, and this 7 portion is connected to 5. So to jump towards to get the exact permutation, I just need one rotation, or like nth rotation basically, but it doesn't matter, like it's just one rotation. So if I want to sort my permutation, I could just rotate that cycle, right? So 5 6 7 and 5, I just need to rotate this cycle basically. In other words, you can see it as like what was the correct position, and you keep moving towards the correct position, right? Like 5 ka correct portion, 6 ka correct portion was on 6th index, so you move 6 towards 6. Now 7 ka portion, correct portion was on 7th index, you move 7 towards 7, something like that. But how is this connected to d task? I will show you that. So D task was, you are given a permutation, right? Permutation of 1 to n. You are given a permutation. Now what you could do is select a subsequence of even length. N is also even. Select a subsequence of even length. Any length it could be, except for 0, right? Subsequence of even length, and the condition should be max is less than mean, or mean is greater than max. Oh, what does it mean exactly? If I chose subsequence of even length and the numbers are something like t1, t2, t2, let's say my length is L, 2L, let's say t2L, right? So until t1, t2, TL, there is half portion, and from TL plus 1 up to t2L, this is another half, half 1, half 2. Okay, so what I could do, if first half maximum is less than second half minimum, or first half minimum is greater than second half maximum, I could remove this entire subsequence. This was the task, right? And I need to print how many minimum number of operations? How many minimum number of operations are needed? This is the trick, by the way. Like, if you want to write the number of something, you can always use hashtag. How many minimum number of operations are needed? So, my first thought was maybe we could uh, like the thought was like there were like two thoughts after just seeing this question. First thought was number of operations could be either one or two. Then I thought I could not prove it instantly, so I thought maybe it is possible that total maximum number of operations that we can remove the entire permutation could be a log, like the blurred thought process, you could say. That I don't have any proof, but the blurred thought process, maybe it might be related to tree or something, permutation tree, and then uh, the total at most the depth is at most log or something like that, or so a very blurred thought process, like just after seeing the question with no proofs. So it was something like that. Then I got to conclusion that one is easily possible. Then after working on some cases, I saw that it is always possible that answer is two. And even when I submitted the code, I was not exactly sure I needed to prove it, but the hence I guess they called it as like guess forces. Most of the people who submitted didn't have exact proof. Even I didn't have exact proof. I proved it after. So so I saw that after working on most of the cases, you can see answer is either one or two. One is easy, that first half is max is less than mean, right? So 1 2 3 4 5 6, something like this, that it is sorted like this, or 4 5 6 1 2 3, anything is valid, right? So if one of this is true, then our answer is one, else answer is two. But if it was the simple question, it could have been a, but it is not the case. We also needed to print what exactly the subsequence was, that will be removed from the task, right? So the moment this happened, my other thought process was how to make sure that I could remove those sequences. Then I gave the same thought process as we do in the exchange, greedy exchange, or like anything, that I will just construct the identity permutation like this thing. And what I will try to do is assume this as like two sets, S1 and S2. So the moment I exchange one number from this set to another number from this set, what happens on the number line? You can see. So let's say my sequence was 1 2 3, and there are only six numbers, and my permutation could be anything 3 2 1 5 4 6, right? So if you plot them on x-axis, it looks something like this: 0 1 2 3 4 5 6. The first portion is 3, so 1 comma 3. Second is 2 comma 2, and third is 1, basically. So this was my this quadrant, and another quadrant was 4 comma 5, which is, let's say, this value. 4 comma 5, and another one was 5 comma 4. So 5 comma 4 is here, and 6 comma 6, 6 comma 6 will be here. So if you notice, this was the balanced case, that for answer for 1. Now the moment I exchanged any number, because obviously we are, if we want to create a new permutation from this permutation, I need to swap something. But I know I will not swap with first half within the same halves. Basically, I will not swap 4 with 6, 4 with 5. I will swap something from first half and something from another half. But the moment I do that, uh, these numbers will be getting pushed to other quadrant. Like let's say I removed, what was this number, 3 comma 1, right? The moment I exchanged this 3 and 4, my new permutation becomes 4 2 1 5 3 6, right? So after this 4 2 1 5 3 6, this becomes 1 comma 4. Sorry, here 1 comma 4, the new number I will write in blue. 1 comma 4 is the new pair, and you can see it moved. This quadrant was empty initially, but the moment I did the exchange, this got pushed into another quadrant. And similarly, this number, uh, which was like 3 comma 5 comma 3, it got pushed into another quadrant. Why is that? Because we know that each element indexes and values were greater than equal to n by 2, and here same case, less than n by 2. But the moment I did the exchange, the indexes got less than n by 2, and the values was greater than n by 2. So it, the quadrant got changed for both of the cases, right? So now you can see that this is still symmetric. So if I chose to and you can see that if I chose entire set of this, the max is still less than mean of this number, right? Because it is already lying on the upper side of quadrant, and this is lies below the quadrant, right? Like in this quadrant, so all the numbers are smaller than this number. So this was kind of visual proof for this task, that you have the balanced case, and the moment you move towards another swap two numbers to create another permutation, uh, you can always create those sequences. So all you need to do is just check what is less than equal to n by 2 and put it into operation 1 for I less than n by 2, right? And for greater than n by 2, like just combine these pairs, basically these quadrant pairs, right? So the moment you did that, you can just pair this thing, like less than equal to n by 2 and value less than equal to n by 2, union greater than equal to n by 2, value greater than equal to n by 2. This is the first operation, operation 1. And operation 2 is basically less than equal to n by 2, value greater than n by 2, not equal to, greater than, it's greater than. Okay, so here less than equal to n by 2 and value greater than n by 2, or greater than n by 2, value less than n by 2. Operation 1, operation 2, and within two operation you can delete the entire subsequence. Everyone understood this logic of how is this working? Before this, I also thought some LIS solution, like maybe it is the because usually this also is, this task is also similar to the chains, the LIS chains basically, and the Dilworth's theorem, Dilworth chain theorem. So I thought maybe related to that, but why permutation then? If it was the just LIS, then permutation doesn't make any sense. So maybe it is related to cycle, right? And also you can visualize this as a cycle also, right? Like if you try to create the graph, but I guess no, this is the best way to visualize it. I had multiple thought, but I think these are the this is the best way to imagine what's exactly going on in the operations of D. That we create the first half balance set and another balance set, and we try to swap it with another one, and just by seeing that we know this got the moment we did swapping with another one, it will get pushed into two different quadrants. One number will get pushed into, like let's say I will use some other color, A, B, C, D, let's say. So let's say all numbers were in B and D, right? And A and C was empty quadrant, right? So the moment I did some exchange between B and D, some numbers will get pushed to only, sorry, if I did one swap or like exchange between B and D, one number will push to C and one number will be pushed to A. This is, if you want to understand the D code, it is something like that. Everyone with me? Uh, we will discuss that in the end, Balishwar. Okay. Then, and this is the simulation that you need to do in your language. That operation one is just all the values that are less than equal to n by 2, value less than equal to n by 2, and greater than n by 2, value greater than n by 2. And similarly, operation 2 and this thing, and print those values basically. That's it. And this is also a sequence, identity permutation sequence. Anyway, doesn't matter. You can create any, I created this balance permutation, but the moment you did the swapping, you can create any permutation from this balanced one. And the moment you do the exchange, the invariant is that one number will be pushed to the quadrant, and the other swap number will be pushed to opposite quadrant of it, right? So if I did the swapping from B and D, if one number got pushed to A quadrant, other number will be getting pushed to C quadrant, and the invariant will still remain the same. That numbers are even basically. So you can just calculate those numbers, and that's your answer. Okay, so if you guys understood this, we will be discussing the most difficult, not difficult, but interesting task. Basically, it was interesting for me at least. Do you guys want to start me explaining the solution of E? Okay, so let's jump to E. E was very interesting task. And E is the task, like it will make people very confused, right? Like those who have not done maths task or not familiar with mathematical concept, like only the x ka portion, increment x, 1 second, meeting disappeared. Arey, shit. Arey, 1 second. Sorry, I thought my meeting disappeared. It was here only. Okay. Cool. Let me minimize this problem set. Where is okay. The thing is, like, if I minimize this window, I can't see the problem set, and this window is too big. Let me minimize it a little bit. I can't see the chat basically if you ask any question. Okay, let's start with E. Let's use different color. Counting is fun. It is indeed. Okay, so the task is you are given a tree, and obviously given a tree, it means that you have n minus 1 edges and n nodes, right? Although in this task, the tree structure has very less relevance in the thought process or in the outline of the solution. So the first thing you should do in such tasks is just imagine it as a linear tree. Imagine it as a linear tree, and they have given first thing, you have given a tree. This is one parameter, and another parameter you are given is basically C, which is cost, right? And there is a visiting condition, DFS condition, you could say, that let's say this is my tree, 1 2 3 4 5 6 7 let's say consider 7 age only. Okay, so you start visiting one, right? we are starting with x equal to 1, right? And let's say my permutation here is 1. So if I did x equal to 1, uh, and I need to assign the cost. I need to, I have basically n minus 1 numbers, 1, 2, 3, up to n minus 1. Why? Because I need to assign numbers to this edges. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So these are the numbers I have been assigning to my edges. And the thing is, now I uh, start, the goal is to visit all the nodes of tree. The goal is to visit all the nodes of tree. So if I start from 1, I could stay at 1, or I could move towards 2. But to move towards 2, I need to make sure that it doesn't match with x equal to 1, right? No, sorry, it doesn't match with whatever the value of x is, right? Here my value was 1 and it is matching with x equal to 1, right? So before that, to move towards 2, I need to increment x equal to 1 to 2, right? 1 to 2. And then we start moving from 2 to 3. Now if I want to move to 2 to 3, my x value was 2, right? Then again I am forced is the word here, forced to increment 2 to 3, x equal to 2 to 3, to move towards 2 to 3, because the value is matching with this. Now this is your first thinking part. How uh, like whenever this tough tasks are there, na, like you are basically stuck. So what you need to do, this is kind of like heuristic brain approach, right? What's heuristic brain approach? That you will kind of reduce your task into some subset of tasks and think upon them. Like there must be something, some observation. So if you can't think a broad level observation, you try to write down the cases, test cases, and smaller cases. Like let's start with simplest case. Like whenever there is a tree, I always linearize the tree, like I did in this case. Then I start by writing just 1, 2, 3, 4, 5, 6. Let's forget the permutation, everything. Just try to uh, find the exact cost needed, right? Or like how we could force my x to increment, because whatever the x value is, that's basically my cost at the end, right? That's the cost. Now let me check again. Perform the operation B. Whatever the x value, how many times the x is incremented, that's my cost, right? So because we need the cost equal to c, this is the parameter given to us. So I need to make sure uh, how we can force my x to be incremented. So uh, you could think it as like a key and door. To pass through door, I need something for that key, right? So now let's say I am at here 1, right? I am at 2. uh, I need to go from 1 to 2, right? So my key should be at least x equal to 2, right? To go from 1 to 2. After that, I could also go towards 3. But the thing is, this 3 and 2 are my sites to move towards, right? So at my x should be at 2. So I could do something like, let's say my structure of doors is something like this: 3, 1, 2. Forget the 3, 3, 1, 2. I start with x equal to 1. I have two choices here. Either I could go from, I started from this, and either I could go from 1 to 2, or either I could go from 1 to 3, right? So the moment I went from, we basically we started from here, but my x equal to, it was x equal to 1, so we didn't care how we got until 1, right? So when I got from 1, if I need to move from 1 to 2, I need to increment my x equal to 2, right? Now I am forced or constrained to use whenever I need to move back here, right? Whenever I need to move back, one of the values I should meet in the travel route towards the doors. Like if I need to visit all the doors, I need to make sure that my values are being passed to that door. I guess I'm maybe confusing you. Okay, let's make it more simple. Uh, mm, 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 mm. Okay, so this one to wala case is simple. Let's take a simple case, more simple case. The door key value is lock is basically 1 and 2. So when we are at x equal to 1, I can't use x equal to 1 or use x equal to 1, something like that, like both of the problems variation. But I will just use the definition used in task, that the value should initially x equal to 1. So the moment I need to go from 1 to 2, this value should not be equal to x. I went from 1 to 2, value got x equal to 2, and then 2 to 3, then this value should not be matching and this became x equal to 3. So how you can say that my value has compulsorily been increment to at least 3? How we can say that? So there is observation here, that if I choose the direction or set something like this, like let's say my set was, in this case it will work like any permutation of 1 2 3, 3 2 1, 3 1 2, anything, right? 3 2 1, sorry. Permutation is not the tree is linear, permutation is the edges combination. So this we will change. Initially it was 1 2 3, now I could select 2 3 1, right? So the moment I start from x equal to 1, same tree 1 2 3 4. By the way, here this numbering doesn't matter. All we are trying to figure out the pattern for how we can force the x to be incremented, right? So 2 3 1, and the moment I am here, my x equal to 1. Okay, it doesn't matter, x equal to 1, then 2 we can move. This is not equal to 2, we can move from 1 to 2. We can move from 1 to 2. We are at 2 now. Now x equal to, my x is still equal to 3. It doesn't matter, like it is not getting incremented, right? 2 3, and my x is still equal to 1. I can move from 3, and then when I'm trying to move towards 1, I need to increment my x equal to 1 to 2. When I'm at 4, my x got equal to 2, then I can move from here to here. X equal to 1. Okay, I can move from here to here. So when I'm here, I got x equal to 2. This value is not matching, then I could x equal to 2. Then I'm moving here. Because this is not matching, I could still move from 1 to 2. And then uh, I could move, not move, because like this is the 2 wala portion. Wait, wait. How is this working? This should not work, because my initial assumption was when you are putting 1 2 3 1 2, it should be, but how 1 2 wala portion? Let's say I put 2 left to it, 3. Then this is just k minus 1 factorial. This was my initial mistake when I derived the equation. Initial mistake. X equal to 2. Then we move from x equal to 3. My x is equal to 2, x is equal to 2. Got forced to increment. and force incrementation is still valid for this. Force incrementation is still valid for this case because I need the value to be incremented at least 3. At least 3. So my permutation should be 2 raised to the power k minus 1 or 3 at least. So it should be 2 square 4. So what the equation was like, the thought process was, I don't know, that when we are at 1, to make the value cost to be at least k, let's say, right? uh, at least x, I need to make sure that I'm inserting in such a way that 1, first I'm inserting 1, then I could insert 2, either this side or this side. So after that I will insert 3, either this side or this side. So my permutation could be looking something like this, either 1, and then starting from 1 it could look like 1 2, or 2 1. Then starting from 1 2 it could look like 1 2 3, or 3 1 2, 2 1 3, or 3 2 1. But this values are not matching with any of the values here. Hence I'm confused that why my x is getting incremented to 3. Because this should not be the case. What a mistake am I doing in calculation? 1 2 2 3 3 4 2 2 3. Okay, let's discuss this. Let's keep it on hold. Keep it on hold. Maybe I'm doing some calculation mistake or assumption mistake. Okay, so this was the calculation part. Initially I calculated that number to be k minus 1 factorial, right? Because I could permit it at any way and those k edges. And the observation here was, if I need my cost to be at least x, I need to form chain of those nodes, right? And this chain can be to label it with 1 2 x minus 1, right? To label it with 1 2 x minus 1, my cost will be at least x. This was the observation. This was the observation 1. Observation 2 was like, let's say I found the chain, whatever my chain was, right? The chain could be anything, like let's say this is my tree and I need only 2 values. This is the infinite tree, let's say. So I could put those chain numbers anywhere, like let's say 1 2, or I could put it here 2 1, anywhere, like if my chain is 1 2 basically, or 2 1, I could insert it anywhere. This middle nodes we don't care. All we need is that this should be in the chain, basically from root to some vertex, right? This was the condition, that to root to vertex, sorry, here the vertex is this thing, ending at this vertex, something like that. Now after this is mathematical question of pure maths after this, that once we got this observation, this complex observation, after this it's all placement issue, how we could place those numbers, right? Because we know this chain contains k minus 1 numbers or x minus 1 numbers. I am using k because definition I used in editorial is k, right? How many charging? 8%. K minus 1 I need to place, right? So the moment I place at V, ending at V, I will teach you one more thing before this. Uh, to count the distinct, let's say two entities, I have taught this 4 years ago. Two entities are distinct if one contain at least one difference. At least one difference. Different element, you could say, or different, right? So let's say 2, 3, 5 is my set. 1, 3, 5 is the set. Here, 1 is different from 2, but we don't differ it like this way. All you do is something like this, that this is empty and 1 is not present, 1 is present here. So these sets are not equal. That's it. So to count the total number of solutions will also be based similarly, that we chain ending at V1 is different from chain ending at V2. Both of this chain are different, right? Obviously, it's different. You can see here. This is ending here. This is ending here. So all we need to find is how many chains can we place if it is ending on V vertex. Please let me know. Even if you don't understand this, 2 raised to the power k minus 1 observation, it's okay. I will discuss that. But you should understand this thing, at least, that we got a chain of k minus 1 edges. We are calculating how many chains I could place that are ending at V vertex. And that is also very simple because my chain is fixed. Chain is basically a linear chain, whatever the 1, 2 combination, right? And k minus 1 edges. So 1, 2, up to dot, 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 up to k minus 1 edges. So these edges you are placing between up to the depth of V, height of V basically, right? So let's say here my height of there are like 3 edges until V, and I need to place 2 edges. K is basically number of nodes, and k minus 1 is edges between those nodes, right? So total combinations become depth of V C k minus 1. Now for each vertex, uh, it will contribute to different chain, right? And this is the way total number of ways to place those numbers, right? So you can if you rotate it like this, you are ending here at V, right? My last element is fixed. All you need to do is choose the combinations, like where you could place the remaining numbers. Like there are k edges, no, sorry, not k node, it was k edges basically, and the first node is fixed here, and remaining one is k minus 1, and you need to choose how many let's say total number of this was depth of V, let's say 4 is basically how many total number of edges. And so how many places we have total depth of V minus 1, because this one is fixed for one node. Depth of V minus 1 total places. And how many objects we have k minus 1 objects, or k minus 1 edges to place between them. So how many combinations? It's just the NCR of this, depth of V minus 1 k minus 1, right? So this is done. Like we placed k minus 1 edges. Now how many edges are remaining, or like how many numbers are remaining to place? So it's n minus 1 minus k factorial, because this was ending at V, but obviously there are like multiple edges, right? Like this is a tree, You could say this is a tree. So we need to also place this, we need to also fill this edges, right? Remaining edges, because total number was n minus 1 and k we have already filled. So n minus 1 minus k factorial are the total number of ways to fill the remaining numbers. Ways to fill the remaining numbers. Okay, n minus 1 minus k factorial, right? So this was the one thing, ways to fill the remaining numbers. Now you need to combine all of these factors, like this and where is this 2 raised to the power k minus 1. Okay, so the total number of chains becomes valid chains that will force the cost to be at least whatever the n portion is less than equal to x. There will be 2 raised to the power k minus 1, right? So 2 raised to the power k minus 1, basically you could say it's greater than equal to k. Fact 1, 2, and 3 is 2 raised to the power k minus 1. Now you need to multiply all this together, because either I could choose age chain ending at this thing, and how many remaining numbers are we are placing. This is another combination, and how we are internally reorganizing that chain. It's depending on this 2 raised to the power k minus 1. So in total, our answer becomes function function of k becomes depth of v minus 1 k minus 1 into 2 raised to the power k minus 1 into n minus 1 minus k factorial. This is way number of ways to place remaining numbers. Number of ways to make a chain so that it forces the cost to be at least x greater than equal to k, sorry, right? And this is the total number of total ways to place the chain, to place that chain. Don't get confused that chain is connected to each other. Like, even though we are just considering chain to be like this, that path from root to that v contains the same sequence as the chain. Like, let's say chain was 132, right? It will not be 132, something like that, but chain is 132. So from my path from root to that vertex, fixed vertex, obviously we will do this for all vertex. We will do the summation thing for this, right? Summation for all v except for one. We will do that. And from root to v, our sequence should be like this. So we can place 132 here, or I could place 1, then gap between, and then 3, then gap 2, or 1 gap 3, gap 2 v, something like that. So these are the ways. Hence, depth of v minus 1, k minus 1 is total number of combinations, that how we can place 132 in this until if it is ending at v, something like that. But this is for greater than equal to k cost, right? We need exact k cost. Now, the moment my function says my cost is greater than equal to k, what I could do to get exact k answer, I could do function of k minus function of k plus 1. So whatever solutions that were giving solution set that was giving cost greater than equal to k, my k plus 1 will be removing those cost, and you will get exact k. And this was the answer basically for this question. Let me know if you didn't understand any portion of this. Connect charger until then. Everyone with me for this task, or you guys are like totally confused what's happening?
Yeah, Navneet, I recently joined, so I have very less idea, but I am seeing like if I get something.
Okay, okay, no issue, no issue. Uh, I guess only one or two people are remaining now. So
This is which E problem or
yeah,
which
yeah, E task, E1.
other? That might be hard for me to get at a moment when I don't have much
Yeah, yeah,
context.
there are various observation. Even I got confused, like this 2 raised to the power k minus 1 thing. Na? Like initially my answer was k minus 1 factorial. Then I thought I understood the 2 raised to the power k minus 1 observation. Then I again got confused, like why k minus 1 is not valid. Now I am getting confused again. But okay, like I think the answer is 2 raised to the power k minus 1. It's something that like we will place the first stage to force the cost first number, then second number, then we can place three either this side or this side. There are only two ways to do that. So each time we are placing the number, we have two choices. So there are like 2 raised to the power k minus 1 choices, something like that. But we found some counter example for this here, that 231 is also forcing the cost 231 is also forcing the cost to something like that, that we are visiting all the nodes. Wait, let me check the statement again. The statement was that we need to visit the node again. You must start at node 1 and return to node 1. Yes, we must start at node 1 and return to node 1. 1 2 3 x equal to 1, x equal to 2. Sorry. I got it now. So let's say I go start from x equal to 2. Uh, I checked x equal to 3. Initially, if I changed x equal to 1, I got x equal to 2. Then I'm not forced to increment at all. The moment I did x equal to 1. Sorry. Then it is correct, right? Like that's not a corner case. Got it now. So 231 was there, right? So the moment I did start with x 2 x equal to 1, I passed through this door. I passed through this door when x equal to 1. Then when I'm at 3, my x equal to 2, I will not increment my x at all. Now I can pass through any door, x equal to 1, x equal to 2. I can go to 2 to 3, 3 to 1, 2, 3, 1, basically, right? So uh, uh, if it is equal to x equal to 1, x equal to 2. Mm, But when I'm at here, my cost is getting incremented towards 1, x equal to 2, got incremented to 3. Making some mistake and I'm not getting what mistake am I making. Like what initially my initial answer was k minus 1 factorial instead of 2 raised to the power k minus 1. But when I put editorial on code forces, they told me that it's 2 raised to the power k minus 1. Then thought, okay, they might be correct because they were the problem author. And even with k minus 1 factorial, my answer was matching for sample cases. Now I am thinking why this 2 raised to the power k minus 1 thing is correct. Because in this case, I'm not forced to place the numbers like this, right? Like initially I thought like they were saying 2 raised to the power k minus 1. So I need to place something like this, that start with 1, then either place 2 here or here, then start with 3, place here or here, and here let's say 3 1 2. But here my combination is 2 3 1. So this is very weird for me because still my cost is getting incremented towards 3. Maybe I'm doing one mistake that x minus 1 should be cost should be at least x. So we need to place 3. Label it as 3 minus 1. Ah, okay. I will add it in editorial maybe or change somewhere in the comment description because I am also confused now why this is 2 raised to the power k minus 1 because initially I thought k minus 1 factorial is the answer, but then 2 raised to the power k minus 1. Maybe I'm missing something because I guess I'm mistaking through the my uh, definition itself that because I need the cost to be at least 3, right? At least 3 greater than equal to 3. So making sure that my permutation is like that, my cost will be greater than equal to 3. But yeah, like this one should be valid now. Then this is the part I'm not getting why it is working. We start with 1, then we start placing 2, 3, 1. Okay, let's leave it. You guys understood the age placing part now, like this portion you got now, like we if we are at v, how many edges we can place, like this we need to sum up for every vertex basically. So factor 1 summation of this factor 1 into factor 2 place remaining numbers and this factor is 2 raised to the power k minus 1, which is correct answer. But I don't know my why can't I prove this is to be 2 raised to the power k minus 1. But yeah, this one was depth of v minus 1 and c k minus 1 and minus 1 minus k factorial and 2 raised to the power k minus 1 is the third factor, and multiplication of that will give you cost cost of uh, cost greater than equal to k. And to get exact k you need to calculate function of k minus function of k plus 1. I will add it in the description what mistake I'm doing. I'm not getting what mistake I'm doing now because I thought I understood it, but I guess I am not. 2 raised to the power k minus 1. But anyway, I will add it in description. All you need to think is three things, which is the chain, how we are placing the chain, how we are rearranging the chain, right? Rearranging the chain inside is 2 raised to the power k minus 1 factorial. Sorry, this 2 raised to the power k minus 1. 2 raised to the power k minus 1 is rearranging number of ways to change so that the cost is forced to be greater than equal to k, and how we are placing this in until v is this total number of ways, and uh, remaining numbers we can place anyway, right? So that's the remaining number placing way. Yeah, that's the editorial for e from my side. Not perfect, but okay to understand, I guess. Any questions?
Uh, yeah, Namit, it is not regarding this, but regarding the course, if I can ask, because this I
Wait,
have.
wait, wait. Let me let me complete the recording. Like for this, I will. We could discuss that. First, let's discuss only related to this. Any question queries related to this? Like ask honestly to yourself. Like what part you didn't understand, so I could explain it to you. So it will also be helpful to other people. I have not participated in this contest, so I have not given enough time to solve the questions. I have just solved on top level. I have also submitted the code. It's ICPC on the CodeChef website. and it's AC. So I haven't given much thought after that, like how my solution is working and all. But yeah, like this is the correct formula for this. Okay, then I will stop the recording for this 2 raised to the power k minus 1. I will add maybe the explanation in description. But yeah, we will stop the recording here, and then you could ask other questions. Stop. Manage recording. Stop recording.